So we're moving into a new unit. We're talking about angle relations, specifically angle relationships. So the first lesson of this unit, we're talking about the different relationships that angles have. So the first kind of angle we talk about, supplementary angles, and these are two angles are supplementary if the sum is 180, right? So the 180 degrees, this angle plus this angle is equal to 180 degrees. Complementary angles, if their sum is 90. So this angle plus this angle is equal to 90. So the way that I kind of try to remember the difference between supplementary and complementary is that complementary angles create a corner. So the complementary makes a corner for the 90-degree angle to fit in. Opposite angles, when two lines intersect, opposite angles are equal. So these two angles are equal, and these two angles are equal, or the exact same. When we're talking about angle relationships in parallel lines, we have different types of relationships here. So the first one we have, alternate angles are equal. So alternate angles would be one that fits in here, and the other one that fits in here. They are alternating. Or I look at it and I see a Z pattern. Right? We can see how that creates a Z. So alternate angles are equal, or I just think of it as a Z pattern. When we talk about corresponding angles, angles that create the letter F pattern. Right, so we can see how the letter F is created here. This angle and this angle are the exact same, or they are equal. The last one we talk about is co-interior angles. Co-interior angles encompass the angles that are found inside the transversing line and the parallel lines. So the lines that cuts across these two angles, when you add them together, they have a sum of 180. Or I just like to write this as a C pattern. If we are having difficulty remembering, okay, this is what alternate angles actually means, what corresponding angles actually mean, and what co-interior angles actually mean, that's okay. If you would prefer, think of it as a Z pattern, an F pattern, or a C pattern. That would get you to thinking about how these angles have those relationships. Some things we already know, some of the angles in the triangle, all of the angles add up to 180. The exterior angles of a triangle, the exterior angles in a triangle is equal to the sum of the two interior opposite angles. So in this diagram over here, we see that the two angles on the inside, alpha and beta, if you add them together, you will get the angle value outside of the triangle. So alpha and beta are the angles that are interior and they are opposite from the exterior here. Right? So these two in the corner far away, when you add them together, give you the sum of that angle. Angles of an isosceles triangle. So the angles that are opposite the equal sides in an isosceles triangle are equal. Right? And we can see that here in our triangle. These two side lengths are the same, which means that those two angles are exactly the same, or they are equal. So a polygon is a closed figure formed by three or more line segments. A regular polygon has all sides equal and all angles equal. So there's a distinct difference between the two. Polygon is just a closed figure by three or more sides, like basically any shape. A regular polygon has all sides equal and all angles equal. So some quadrilaterals have special names. A regular quadrilateral would be called, well, if I'm looking at something for that's called regular, it has all sides equal and all angles equal. The sides are all the same, the angles are all the same. This is a square. An irregular quadrilateral may be a rectangle, rhombus, parallelogram, or trapezoid, right? So I'm not going to worry about drawing these shapes and draw appropriate markings to show equal signs. If you know those shapes, I'm okay with it. I really want to kind of cover how to find angles using those angle relationships that we talked about above. So I've highlighted the examples that I'm going to go through. I'm not going to go through them all. Find the missing angle and state the theorems you used. Okay, so example A, we see that these two lines are parallel lines, and the transversing line creates a bunch of things. Okay, wait, I have 100 and I have an unknown. Well, I know that I can use my co-interior or my C pattern, and when I add those together, it has to equal 180. So I'm just going to go co-interior is equal to 180. So in this case, 180 minus 100 is going to give me my unknown value. In this case, would be 80. All right, so this unknown value is 80 degrees. And this is simply just proving how we go ahead and solve that. You can look at this and be like, okay, I know that's 180 minus 100 is 80. You're good to go. Example C, we have lines that cross and intersect, and we know we have opposite angles here. So based on our opposite angle, B is equal to 43 degrees. We don't even have to do any math. We can just state that according to the rule, since these are opposite angles, they are in fact the same. Example F, we have, and this is going to give myself some more space to write, we have 40 degrees, we have an isosceles triangle, and we're trying to find unknown angle X. Well, I know that the interior angles of a triangle are 180, and then I take 40 away from it. So 180 degrees minus 40 will give me 140. Well, that is not what this angle is, right? Because there's two of them, because these sides are equal length. So these angles are the exact same. So I take 140, which means I then have to divide it by 2, which would give me 70. So then X equals 70 degrees. Let's go down. Example 2, solve for X and state the theorems that we used. Okay, so as you notice, it looks a little bit more complex than just simply finding the unknown variable. Now we have a little bit of algebra in here representing the angle relation. So that one we have 2x plus 3 on one side, or 2 plus 3x, pardon me, degrees, and then 62 on the other. Well, I know that they're opposite. I can see that. The opposite theorem, which means that 2 plus 3x would be equal to 62. Now this looks like a format that we can solve. I could then go 3x equals 60, x equals 20. So then my variable would be 20 in terms of finding the angle using our opposite angle theorem. Next example I have, scroll down for C. Okay, I'm trying to solve for X. Pieces of information that I know. I know that this is 90 degrees. I've been given 40, and I have 6x plus 2 as the other degree angle. So I know that this, since this creates a 90 degrees, I know that this creates a 90 degree as well. So I can say that 40 plus 6x plus 2 is equal to 90. It creates a 90 degree angle. Now I can go ahead and solve for my variables. So then I have 6x plus 2 equals 50. 6x equals 48. My x value ends up being 8, right? So just identifying, okay, what can I do with the piece of information that I'm given? Set up the equation that I can use based on the theorems, and then go ahead and solve for the variable. Example F, we have 20x plus 5 and 24x minus 1. Lines are parallel, and they are both on the inside. This is co-interior. So the co-interior angles must add up to 180. So 180 is equal to 20x plus 5 plus 24x minus 1. Now I just go ahead and solve for my variable. I end up getting 44x, and then on my left side, I have 180 minus 5 plus 1, which gives you 176. And then divide both sides by 44. I end up getting an x value of 4. Third example, I think I got just 2 more here. Find the missing angle and state the theorems you used. Show all steps. Now you'll notice I'm not necessarily stating the theorems, 1, because I have limited space, but 2, if you know how to go ahead and solve for the angle, that's fine. I'm not really going to be looking at, do you know what this theorem is called? If you know that the theorem is true and you go ahead and use it, that's totally fine. Or if you tell me that it's the C pattern, for example, or the F pattern, I'm good to go with that. It doesn't have to be as technical as stating the actual theorems verbatim. Example A. Okay, we have 2 triangles. We're trying to find this angle here. Well, wherever I'm trying to find the unknown, I always ask myself, can I, in one shot, figure this out? Well, no. I know that all the angles inside a triangle are 180, but I'm missing 2 pieces of information, so I can't really do anything. But on my second triangle, I can actually determine this angle based on the sum of the interior angles of a triangle. 35, 23, and unknown, or x, is going to be 180. So I can just simply write that down on the side here. So I label this as the first thing I'm going to do, number 1. Number 1, 180 minus 35 minus 23 is going to give me a value of 122 degrees. So this means that this angle here is 122 degrees. Now I have 3 triangles, but I also have opposite angles here. So that means that this side is also 122 degrees. So I'm then going to use the same approach. 180 minus 27 minus 122 is going to give me my unknown. And I go ahead and do that math. My unknown is equal to 31 degrees. So this here would be 31 degrees. Okay. Last one, example E. So again, we have 2 triangles like this, line that goes this way, pieces of information that are key. This is an isosceles triangle, so 65, and this is actually an isosceles triangle as well, but these 2 side lengths are the same. So if these 2 side lengths are the same, what piece of information do I know about this angle? Well, this is 65, which means that this has to be 65 degrees as well. So I'm just going to go ahead and put that in there. 65 degrees, and we know that based on the isosceles angle relationship. If I know that those 2 are 65, the sum of the interior angles of a triangle is 180. So if I go 180 minus 65, minus 65, minus 65, I end up getting 50. So then this is 50 degrees. So then this angle here is 50 degrees. Now we know that on the opposite angle theorem, this is also 50 degrees. So I now stated that that's 50 degrees. I'm now entering into the other triangle. I need to find this x value. Remember how these are isosceles triangles, so this side length is the same, this side length is the same, which means that this angle and this angle are the same. Well, that's also 50 degrees. 50 degrees there. Now we know that we have 180 minus 100 gives us a value of 80, which would be 4x. So there actually wasn't a ton of math involved once we determined which theorem we wish to use, and we can go ahead and use those theorems, apply the angles that we know, and then start solving for variables.